Understand that ideal solution will follow Raoult's law. Now we're going to have a look on non-ideal solution which not following Raoult's law. Not all mixtures of miscible liquid will form ideal solution. There are some liquid mixture which deviate from Raoult's law. Consider this graph, vapor pressure versus composition. When the total vapor pressure of a solution of two miscible liquid is higher than the calculated using Raoult's law, it is said to show positive deviation from Raoult's law. Okay, so you see this curve. This is total pressure which higher than predicted by Raoult's law. When the total vapor pressure of a solution of two miscible liquid is lower than calculated using Raoult's law, it is said to show a negative deviation from Raoult's law. From the table, we can see the difference between positive deviation and negative deviation. For the positive deviation, the total vapor pressure of a solution of two miscible liquid is higher than calculated using Raoult's law, and the negative deviation, the total vapor pressure of solution of two miscible liquids is lower than calculated using Raoult's law. The attractive forces between the mixture A, B is less than the pure solvent itself, which is A, or B, B. Compared to negative deviation, the attractive forces of mixture A, B is more compared to the attractive forces of individual A or B. For the positive deviation, it increase the volume of solution and it involve endothermic reaction whereby temperature is decreasing. Compared to negative deviation, it decrease the volume and it involve exothermic reaction where the temperature is increasing. A mixture of two miscible liquids A and B will show positive deviation from Raoult's law if the bond between A and B in the mixture are weaker than the bond between A and A or B and B in the pure liquids. So the molecule have higher tendency to vaporize in the mixture than in the pure liquid, causing the vapor pressure to be higher than expected. Due to weaker bond in the mixture, mixing of the solution is accompanied by an increase in volume and absorption of energy. And there will be decrease in temperature. One example of positive deviation is a mixture of ethanol that have boiling point 78.5 degrees Celsius and tetrachloromethane which have boiling point of 61.2 degrees Celsius. On mixing, the strong hydrogen bond between the ethanol molecule, this is in pure ethanol, are replaced by the weaker van der Waals forces in the mixture. Let's consider this boiling point versus composition graph. Okay, we consider this region first, which is A region. If a mixture of ethanol and tetrachloromethane with a composition of C1 is fractionally distilled, the composition of the vapor will change until the point Z here, where the mixture containing ethanol and tetrachloromethane will distill at 59 degrees Celsius. Okay, here. The remaining in the flask get richer in ethanol, which distill at 78.5 degrees Celsius. Okay, if a mixture with a composition C2 in region B is fractionally distilled, the first distillate is a liquid mixture of ethanol and tetrachloromethane with composition Z, followed by pure tetrachloromethane at 61.2 degrees Celsius. If a mixture with composition Z here is distilled fractionally, the sole distillate is a mixture with composition Z, which distill at 59 degrees Celsius. The mixture with composition Z is known as an azeotropic mixture or an azeotrope. The azeotrope is a mixture with constant boiling point where the vapor is the same as the composition of the liquid. We're going to have a look on the azeotropic system later on. Okay, so a mixture which shows positive derivation from Raoult's law cannot be completely separated. The fractional distillation will yield one pure liquid component and azeotropic mixture. Trichloromethane ether mixture is the example of negative deviation. There are van der Waals forces between the ether molecules and trichloromethane molecules. When trichloromethane and ether being mixed in a mixture, the hydrogen bonding will form between trichloromethane and ether. So the attractive forces of the mixture trichloromethane and ether is higher compared to its pure solvent. We consider first region A. If a mixture with composition P is distilled fractionally, the first distillate is pure trichloromethane, which is at 61.2 degrees Celsius, followed by azeotropic mixture Z containing 20% ether and 80% trichloromethane at 64.7 degrees C. For the region B, if the mixture with composition Q is distilled fractionally, the first distillate is pure ether, which is at 35 degrees Celsius, followed by the azeotropic mixture at 64.7 degrees. If the mixture with composition Z is distilled fractionally, the sole distillate is a mixture with composition Z. The mixture with composition Z is known as azeotropic mixture or an azeotrope. So the negative deviation shows from the Raoult's law cannot be completely separated, and fractional distillation will yield one pure liquid component and an azeotropic mixture. One simple example, in the question given pure ethanol that have boiling point 78.5 degrees Celsius and pure water that have boiling point of 100 degrees Celsius form an azeotropic mixture with composition of 95.6% by mass of ethanol and boiling point of 78.2 degrees Celsius. Sketch a boiling point composition graph for an ethanol water system. So label the axis. Okay, so the y-axis is temperature, which is degrees Celsius, and the x-axis will be composition. So we know that the boiling point of pure ethanol is 78.5 degrees Celsius, and boiling point of pure water is 100 degrees Celsius. So this is 100% percentage of water, and here will be 100% of ethanol. From the question, there are azeotropic mixture with composition of 95.6% of ethanol. So meaning that at 95.6% of ethanol, there are boiling point of 78.2 degrees Celsius indicate to the azeotropic mixture. So the azeotropic mixture contain 95.6% of ethanol and 4.4% of water. So you need to label the azeotropic mixture. And from the curve of the graph, we know that it is positive deviation. So you must be able to indicate the positive deviation or negative deviation based on the curve of the given system.